We are 2 talks away from the ending. So in 2 hours we'll be crying the tears you won't see, especially from the internet. Okay, on the first row I see senior developers of different databases, and I said too much Postgres, and they said no, there's never enough Postgres. Alexey, you will continue the talk about Postgres. Please prepare your questions. In 40 minutes we'll ask them. If you're watching us from far away, please use our Telegram channel and hashtag question. Alexey?
Yeah, okay, thank you. My name is Alexey Palazhchenko. Today I'm going to talk about how we built an open source MongoDB-compatible database on top of Postgres. I like this title for 2 reasons. First of all, it actually fits the slide, unlike some other talks today. And second, it's very straightforward. It's basically a plan for my talk, so you don't have to second guess what I'm going to talk about. I'm going to talk about, oops, spoiler, about MongoDB, about whatever it's open source or not, how we are building a replacement, and why we are using PostgreSQL as a storage. So before I begin, let me ask, are there in the room people who consider themselves to be PostgreSQL experts? Raise your hand. No PostgreSQL experts? No one? Okay, maybe one. Okay, good. So first of all, I'm going to talk about good parts of MongoDB. Before we know why we are going to build a replacement, we need to talk about is there anything good or not. So I would say that MongoDB provides a great developer experience. You just take an object in your favorite language and shove it into database. You don't have to think about tables, normalization forms, indexes, whatever. Just shove the whole object and everything will be fine. The reason I asked if they're PostgreSQL experts, because at that moment they will probably just stand up and leave. No one leaving so far, so everything is good. Okay. What else? I would say they have good enough drivers. If you look inside of them, there are a lot of horrors, actually. But again, from the developer experience, API is clear. Method to find some data is called find. Method to update some data is called to update. Everything is reasonable. And they used to have a great community back in the day when they only started. They actually was very open to open source community and community in general. So many years ago, I was involved in a project called Greylog. It's a storage for logs. And back in the day, they used MongoDB to store data. And there was a competition like write an article about how your open source project uses MongoDB. I wrote one, and I won the competition, and they sent me an iPad. That was iPad 2. And it, of course, for me personally, that all went down from there. But yeah, now they don't do that, of course. But still, that was a good iPad. So that's all. What's bad about MongoDB and why we want to replace it? First of all, when they only started, they tried to do everything. And as a result, reliability, performance, scalability wasn't great at all. There was a lot of issues when they lose data, a lot of performance problems. They were not scalable. And if you were around back in the day, you probably remember this funny video. If you don't remember, try to Google. It's called MongoDB's Web Scale. Well, back in the day, it was funny. I'm not sure about how it is now. And as I said, yeah, the reason maybe is that just try to do everything at the same time. So when they started, they worked on storage, on API, on query language, on data modeling, on like everything. They wanted to have all of that. And on top of that, they also wrote drivers themselves. Now, of course, MongoDB is a much bigger company. They're a public company. And as any public company, they have to release some financial statements. And MongoDB keeps losing money. That's a big company that still loses a lot of money. So how are they going to make money? Of course, they're building their own SaaS. So they have something called Atlas, and that's basically a vendor lock-in for them. And to discourage anyone to build their own SaaS solution on top of MongoDB, they changed the license. So originally, I did not want to talk about license a lot. But people keep asking me about, like, okay, what's wrong with their license? And those people include programming community of high load. So I decided to add a bit of explanation of, like, what's the deal with their license. But I have to say it's not a legal advice. We, of course, talked with lawyers, but legal advice is not transitive. If someone gave us legal advice, I can't give it to you. And of course, I'm an engineer, and you shouldn't listen to legal advice from engineer on tech conference. That being said, let's discuss a bit about MongoDB license. So first of all, we need to discuss AGPL, and AGPL is old MongoDB license. First of all, that's a very popular copyright license. That's important that it covers copyright for MongoDB source code. It doesn't apply to anything else. That's just MongoDB source code. And the old license said, okay, so if you modify a program, if you don't modify a program, you actually don't have to comply to any other bits of the license. You can just write and modify it, and that's good for most use cases, right? You don't have to change anything, you just run it. But if you modify it, and then you have to give some freedoms, as AGPL said, to users interacting with it remotely through computer network. And interacting is a term which is not defined, but more or less clear, should be clear for everyone. So, and if you release, allow users to interact with, you have to release a corresponding source. And corresponding source is defined like program source and including control scripts for these activities. What control scripts are not quite clear, but from the context of the license, it's, what they mean is basically build scripts. So you could not release only your changes, and you could not build them without makefiles, for example. Okay, and then they switched to SSPL license, which is their own license. It's not used. It wasn't existed before. Now some other companies switched to SSPL, but they wrote it themselves. So first of all, if you make functionality of the program, so you don't have to modify it. If you expose it through the network, available to third parties as a service, you have to do something. You don't have to modify it. And what is available to third parties as a service includes without limitation and then many, many words. And it's not actually, so the definition is so broad that basically, let's say you make a CRM system. And your CRM system stores data in MongoDB. The primary purpose of MongoDB is to store data. The primary purpose of CRM is to store data. The primary purpose is the same. From the text of the license, one might consider that, okay, you have to release CRM and SSPL because the primary purpose is the same. But again, the definition here is not quite clear, let's say. But then you have to release service source code, and service source code, they like this phrase, including without limitation, and that's a lot of words. And that's problematic for two reasons. First of all, you have to release under SSPL source code that you probably could not release under SSPL. For example, let's say you run MongoDB as a service, as I say, on top of Linux. Technically, you have to release Linux source code under SSPL. That's not possible because you don't own copyright to it. Or if you run it on Windows, you don't have the source code at all, unless you stole it from Microsoft, of course. So what lawyers say that SSPL basically a unique license that it goes beyond copyright. It's not a copyright license anymore, it's something else. So it is not quite clear how to apply SSPL. And big companies, for that reason, try to avoid SSPL as much as possible. But of course, MongoDB tries to say, okay, that's not a problem. We want to avoid Amazon or Azure or someone else to run MongoDB as a service, and we want to make this money, and they say not like freeloaders or something. And they have FAQ section on their website that tries to say, yeah, I mean, that's fine, you're fine, everything is good, we are not going after you yet. But the problem is that FAQ section is not doesn't have any legal weight, right? So if there would be a lawsuit or something else, lawyers will check the legal text, not FAQ. And it actually worse than even that. So they have, okay, so if you don't trust me and you have, as I said, you don't have to trust me, you don't, I'm not a lawyer, you actually can read what open source initiative, the company that defines what open source is, what they think about it. The SSPL is not open source, they are very clear on that. But that goes worse. So there is this change that was made last year, if I remember correctly. That was a change in protocol specification. What they try to say is that protocol specification is under Creative Commons, not commercial share alike license, and they tried to define what that means. So you could not use this material for any commercial purpose, such as to create a commercial database and database service offering. So legal text of that license is quite clear, and nothing in this license prevents you from reading the document. Right? You always have the right to read the document. And they try to say, well, yeah, I mean, we use that license, but we mean that it means something else. So you could read it, of course, but you could not use the knowledge from the document. So that particular bit is actually what triggered me to start FerretDB, because like that's nonsense. Okay, so MongoDB has legal problems, let's say. So maybe there's some other alternative you could use, right? So like that seems to be a database with some good parts, as I said at the beginning. So maybe there are some alternatives. Well, there is like DocumentDB on top of Amazon. It's kind of public secret that it's built on top of PostgreSQL too. So if you're fine with using Amazon and being vendor logged into Amazon, you could use DocumentDB. You could use Azure Cosmos DB, the same thing for Azure. If you're fine with using Azure forever, you could use Cosmos DB. Then there's Oracle API for MongoDB. If you have enough money, you probably could use it, but well, at least they have a better logo than everyone else, right? Something funnier. There is something called Informix database software. I don't know what's that, but they have MongoDB API compatibility. And finally, there is MariaDB MaxScale, which is also not an open source product, but at least that one going to be open source in 4 years. So they use this weird software license called business source license, which basically means, okay, it is not open source now, but it will be open source. This version will be open source in 4 years from now. So in 4 years, you will have open source but outdated version. So there seems to be an opportunity. So what we decided to do, we decided, okay, let's build a MongoDB replacement that could work with unmodified MongoDB drivers and applications. So basically that means that we can take MongoDB drivers, which are under Apache 2 license, or any applications that uses MongoDB protocol, and you don't have to recompile it, change it in any way. You don't have to do anything specific to adopt it. We definitely did not want to store data ourselves, because like building a good database storage solution would take 10 years, and we don't have that much time. And yeah, I mean, we would like completely avoid all reliability problems if you don't store data. And it should be an honest open source solution. We don't want to play license games, BSL, SSPL, whatever, just clear open source license. And then we will like compete with everyone else who could fork our database, for example. So I keep saying like our and we, but who actually we, right? I did not even introduce myself in the beginning of the talk. So the company was founded by 3 people. That's Petr Zaitsev, co-founder of Percona, and until this year, CEO of Percona. He stepped down this year. That's Peter Farkas, who also worked at Percona for many years and was like a lead of service team, and me, who you guessed is also ex-Percona, and I was a tech lead, backend architect for PMM team, for example. So yeah, all 3 former Perconians decided to make an open source database. So it's called FerretDB. That's our logo. And what's that? It's stateless proxy for MongoDB wire protocol. So we don't store data ourselves. We basically accept connections from unmodified MongoDB client applications drivers, convert them to SQL, send it to PostgreSQL. So yeah, we use PostgreSQL for storing data, and we currently support another database which is called Tigris. So Tigris is a new database, and we partner with them. It's actually quite cool. It's built on top of FoundationDB, and if you're interested about FoundationDB, there would be a talk after that one about FoundationDB. And it's under Apache license 2.0. So like as I said, honest open source solution. Okay, so where we launched about 1 year ago with like great success for like after we made some initial prototypes and released them, we got a lot of feedback. So we quit our day job and decided to start a project and a company. We released version 0.7 several days ago, and we plan to release GA generally available version in early February. So by that time, it should be stable. We should not break backward compatibility. We should not, hopefully, lose your data. But of course, yeah, as I said, we don't store data ourselves. Okay, and we are looking for early adopters with small data sets. I'm going to explain why small data sets soon. Okay, so why we choose PostgreSQL? That's an open source project with a huge community, a lot of active contributors, like very old, very stable, very reliable. Old, I mean in a good way. Of course, so like as I said, it takes 10 years to build a reliable database, and PostgreSQL is older than that. It has good JSON support that we, of course, are going to use. And many companies run both PostgreSQL and MongoDB. And many of them said, okay, we actually have experts right now in both PostgreSQL and MongoDB, and it would be easy for us to have experts only in one database, not use several database technologies. So, okay, let's take a look into some internal details. So, as I said, we use jsonb, that's a data type in PostgreSQL for storing JSON, and MongoDB itself uses something called BSON. They say BSON is binary JSON. It's actually not, but MongoDB likes to lie to us, I guess. So one difference between BSON and JSON that field order is significant in BSON documents. So in most languages and in JSON RFC, they say that, okay, that's basically an unordered collection of key value pairs. And in BSON, field order is significant. So the first field of the document is actually a command. So basically, when you set a BSON document to MongoDB, that's command, and the first key value pair describes that command. So somehow we need to preserve order, and JSONb does not preserve it by default. So it's binary representation of JSON. It's reorders fields internally. So how we do that? We store a separate key, $K on that example, which stores the order of the fields. So in that example, we have an object with two fields, platform and application. Application is an object itself. And then we have $K, which stores the order that platform comes first and application comes second. Okay, that's simple, but that $K might be a problem because in MongoDB, the actually dollar fields are used. First of all, they're used for commands. So for example, if you want to update something, you typically set $set command to replace a value, or $inc command to increment the value. And MongoDB actually supports fields, normal fields in data documents that start with $sign, kind of. So that's quite recent additional, and you can't address them directly because they would be confused by commands. And they provide special commands, get field, set field for that. So we asked around if actually someone actually uses documents with dollar fields, and we found no one. So we decided not to support it, at least yet. We'll see how it goes. If you have a use for those fields somehow, for some reason, tell us. Okay, what else? So BSON have more data types than JSON. JSON basically have only what? Boolean, numbers, strings, arrays, objects, maybe something else. But basically, that's all. So BSON have more. First of all, they have 3 different types for numbers. And of course, they behave a bit differently. So double is like a floating point number. int64 is large integer, and you could not, for example, fit a large integer value into float value. You will lose precision. But then they have some weird data types like timestamp. You can say, okay, what's weird about timestamp? That's basically just a time, right? So timestamp is actually a semi-internal MongoDB data type, which is not a time. So they have a separate data type for time. Timestamp is a Unix timestamp plus counter, effectively. And then they have something called JavaScript code with scope. So you may think, okay, so that's actually a stored procedure, right? So you could write some JavaScript code, store it at MongoDB, and run it. That's actually not. What I just described, that's a data type called JavaScript. JavaScript with code with scope, that's a closure. So you could like write a function in Mongo shell that addresses some variables outside of the scope, and both that function code and scope outside of it will be captured and stored in the database. Why someone would need something like that, I have no idea. But they support it, and yeah, we actually looked into that if someone actually uses it and checked if you want to support it. So we store this extra data type as object with special fields. For example, for numbers, we store short integer like just a number, long integer as an object with special field, double as also an object with a special field, timestamp the same, and JavaScript code with scope actually not supported. I mean, no one uses it, and I guess MongoDB is going to deprecate it themselves. Okay, what else? So in addition to all different data types, we also have some bad values in BSON. So of course, null is a problem as usual, but actually there are more values that are problematic in MongoDB that supported. And if you ever worked with floating numbers and like floating point arithmetics, you already could guess it. So they support storing infinity values, they support storing not number values, and they support storing -0. So, I mean, okay, let's try if you want to try to support them. Do you want to store them? Yeah, as usual, we do the same. We store null as null. JSonb supports it. Infinity value we store like that. Actually used to store like that, but I'm going ahead of myself. And -0 is actually an interesting case because if you take MongoDB and save -0 into database and get it back immediately, you will get it back. But if you try to query the same data sometime late, you will get a normal 0 back. I guess there is some background process that basically loses the sign of the 0 in the somehow. I don't know. I mean, that sounds a bit scary how MongoDB basically loses data, but I don't know. So we decided not to implement it at all because that's probably too confusing. Okay, so in addition to store those values, we actually have to compare them somehow, right? So if you want to query data, we want to filter it, we want to sort this data, and this values could be of different types. So in MongoDB, in the same field, you could have string, number, array, object, and we have to compare them somehow. And of course, there could be problematic values. So if you try to compare null and not a number, you will get surprising results. So let's take a look. So none is less than 1. That might be clear for people who use MongoDB for many, many years, but if you try to do the same in SQL, you will get very confusing results. So, okay, so let's assume that not a number less than 0 makes some sense. Okay. Null is less than not a number. When you query nulls values in SQL, you typically have an option. Do you want nulls to be first or last rows in the result? But they say, okay, null is always less than none. Okay, cool. Empty array is less than null. Okay, you can say, okay, so if you have array have kind of a special data type, it's like composite type, and let's say all composite types are less than scalar values. But then we get that empty array is less than array with a single element null. Okay, you can say, okay, so shorter array with 0 elements is less than array with a single element. So far, everything is good. So how do you think if you compare null and array of single element null, what would be the result? The result is it depends on the sorting order. So if you query data in one order, you will get, okay, null is less than array with a single element. If you query in the opposite order, you will get the opposite result. How we are going to support that? that was my reaction when I saw that. So again, if you remember this web scale talk, you probably remember this talk. If not, that's a link at the bottom. It's a talk called WAT. That's basically about comparison of JavaScript values. And that's even more weird than just plain JavaScript. Okay, so originally what we tried to do, we generate, basically our stateless proxy generates SQL queries. That's all it does. So we have to generate SQL queries that we send to PostgreSQL to compare those values. How we are going to do that? We tried our best for quite some time. And those SQL queries were very, very complicated, but code that generated them was even worse. So it wasn't possible for us to support it at the very beginning, so we decided to remove it all. So what we do now, we do comparison, all comparison in Go code. Our proxy is written in Go, that's why. And on every request, we actually currently fetch all the data. Some people are leaving at that point. That's fine. So yeah, if I said that at the very beginning, everyone would probably leave, but now at least you have some context why we do that. Of course, we understand that's not a real database if you query all the data for every single query, right? So like that doesn't scale, that sounds stupid. Yeah, I agree completely. But first, we want to make it work correctly. And after that, we want to make it fast. So what we do right now, we write integration tests for all those edge cases I saw before. Then we decided, okay, maybe we actually don't have to support some of them. So we removed non-values, we removed nested arrays, which are even more complicated than I tried to show you. So all those edge cases, we said, okay, we explicitly don't support them, we return errors. Instead of like silently discarding this data or something, we return errors for that cases. And then we implement simple query pushdown. So what that means that, okay, if we know the data type of the query and we know the value, we could generate simple query. For example, if we query document by ID, and that ID is type object ID, we know definitely how it's stored. So we could generate a query where ID equals that value. And then we query only that one row, not all collection. And we have some ideas for future improvements. So for example, we could, once we have this Go code covered with tests, we could actually translate it into PGSQL functions. And we already have a prototype for that. We could also have custom comparison operator, or we could write a plugin to have our own custom types. So there are many options. We explored some of them, but mostly currently we are trying to cover all the edge cases. So what we're going to do? So as I said, yeah, we are going to remove supports for problematic values. We already did some of them, and we are going to continue with that. We are going to separate types and values. So previously, I showed that that's how we store long integer number. And what we are going to do, we are going to separate type information from the value itself. So that way, we could write a query like that. And in PostgreSQL, that's just a JSON number, and that JSonb field could be indexed effectively. So it doesn't matter what numeric type is that. Is it like short integer, long integer, float number in BSON types? We could query that effectively, and index should work. And after that, we do some additional filtering based on type in the Go code. So again, we will get much less data this way, not the whole collection. And as I mentioned, we have integration tests. So how we test? We have our own compatibility test. Basically, what we do, we generate query and send it to both MongoDB and FerretDB and compare results. And the results are different. We look into that and decide if we want to support it or not. If we are going to support it, we fix it. If not, we return errors in that case. Then we run integration tests of existing application. So we have some applications already fully supported. What we basically do, we start FerretDB and run their own integration test to see what fails. If results are the same, if all tests pass, then we fully support that application. FerretDB is good enough for that application. So MongoDB themselves, they have a set of integration tests that we run. Currently, most of them are failing, but that's because they don't actually have simple cases. Just as we are, they have a lot of tests for edge cases, but we slowly increasing the number of tests we pass. And of course, we have community testers, people who are brave enough to try FerretDB already. And we have some successful reports from people who use it for small data, for small websites, small workshops, stuff like that. So it's already working, despite all those issues I described before. So speaking of community, okay, my screen died there. So everything we do is public on GitHub. We have a public roadmap. All issues are public, all code is public. So if you want to see what we are going to do soon after we do GA, what we planned before GA, you can see all that there. As I said, source code is all public. Please go ahead and start us on GitHub. Stars on GitHub are very, very important. And I'm only semi-joking, to be honest. So yeah, that's actually important for people like VCs. And give us a try. So like you go home today, you rest a bit after the conference and try to run your application that uses MongoDB with FerretDB. Many of them will fail, but at least go ahead and create issues for us. That's all. Thank you. And I'm ready to answer questions.
Hi, thanks a lot for your talk. Actually, I would like to ask, can we consider FerretDB like in-memory database on top of the MongoDB? Let's say if all my updates is go through FerretDB, you will index it in memory, like instead of loading, writing every time in Postgre and reading again. You can keep it in memory, keep indexes in memory, I don't know, like consider like in-memory database with persistent layer in Postgre, basically something like this. Or you like, for each write, you will write and after read everything again back to the memory. Yeah, thanks.
Yeah, thank you. That's a good question. So currently what we have is MongoDB protocol proxy, right? So our code that parses MongoDB queries, like decodes them, sends them to database is quite robust already. We already support 2 backends. And then possibilities are endless. So for example, we had an idea, maybe we could build a MongoDB-compatible interface on top of SQLite. And then you could have embedded database with MongoDB interface. Sounds pretty cool. Then we could build on top of some in-memory database. In fact, there is a company called SAP. You probably heard about that, like huge company. They have a solution called HASA, something like that. Okay, they have in-memory database. And they forked FerretDB to build it on top of the in-memory database. They published a blog post about that several days ago. So hopefully they will work with us soon to bring their changes back into FerretDB. So possibilities are endless. But we need to focus somewhere. And so far we decided to focus on PostgreSQL and Tigris to have 2 backends. So we could like check, okay, so we actually work correctly with both of them. And then after that, yeah, we'll see. I mean, if you have users, customers, clients, that would be for them to tell us.
Hello, thank you for the talk. Very interesting. I will not talk about integrating FerretDB with some in-memory database. Instead, I will ask about what about scalability. As far as I remember, the MongoDB was the database that brings us to the web scale.
Yeah.
So the scalability should be the first idea to keep on. Without it, it's only a Postgres, non-scalable Postgres with MongoDB interface.
So you said that like scalability is the first one. Do you think that scalability is more important than correctness?
No.
So that actually, that's not that clear for me. So we thought about that. So maybe one option for us was to, okay, let's ignore compatibility to some degree. We will return different results than MongoDB, but we will do it fast. But then the problem is, okay, if you develop a new application, that you're fine. But if you're trying to take existing application and run it with FerretDB, you silently will get different results. So first of all, we want to achieve correctness. We want to be 100% compatible with simple queries. So like queries, as I showed, they should work or should return explicit errors, not slightly different data. And after that, we are going to make it faster. So Postgres, I think it's quite fast database, to be honest. But what's interesting that there are a lot of jokes about MongoDB not supporting transactions and joins and all that. And of course, they also support all of that right now. But joins are still not common in MongoDB world. And if you take, okay, you have quite complicated queries with, I don't know, aggregation pipelines, but most of them target a single collection, that's much easier to shard that single collection into smaller shards, given that most queries do not go into like all shards or different collections. So query language itself and applications that use MongoDB tend to be easier to scale, not because of MongoDB itself, but kind of due to limitation of the query language, I would say. And then, of course, we could like, okay, so now we support PostgreSQL, we could support a different backend, and we could support a different backend that provides SQL compatible, PostgreSQL compatible clients. So we already tried to run our test with Cockroach, for example.
Okay,
So
thank you.
you have your scalability now. Yes, please.
Yeah, thank you for the presentation. I would like to ask, do you have any benchmarks?
So it would be a very sad benchmarks if you query on the data, right? So if you like have 100 objects in collection, everything will be fast. If you have millions of collections and data documents in collection and you query all of them, yeah, benchmarks will be set. We are going to publish them anyway because people are asking. But yeah, right now it's bad. I'm honest and upfront about that.
Okay, thank you.
One, two.
Thank you for your speech, Alexey. I want to ask about performance and speed. As it's as speed as PostgreSQL or as MongoDB from speed? Or you didn't have a statistic yet?
Yeah, that's basically the previous question. We are going to publish benchmarks. Right now, performance is not great, but at least, very least again, getting documents by ID should be fast enough. And we are going to publish that benchmarks. So like, actually, yesterday there was a great talk about benchmarks of databases, and we are going to use that tool. We are going to publish results, hopefully soon.
Thank you.
Please.
Okay, thank you. Question, any plans to support change stream in future?
Sorry, support what?
Change stream, MongoDB change stream.
Change streams. Why you need them?
Why not?
Okay, so actually, let's talk after the talk. So basically, we want to know what our customers want. And change streams is something people ask sometimes. But in MongoDB, there are two technologies for that. There is oplog, which is kind of old and semi-deprecated, and change streams. Interesting thing is that oplog is slightly faster, and then many software, for example, Meteor framework still uses oplog, not new change streams. So it seems that we are going to support oplog earlier than change streams, and after that we'll see. But yeah, we are interested in learning about your use cases.
Thanks.
And the final question, please.
Yeah, thank you for the talk. So could you underline the main maybe reasons why customers should use FerretDB? Of course, maybe I have some system which used to have MongoDB and I would like to change it. That's the last one, maybe from the top of the mind use case. What else?
So I would say there are two main reasons we are aware right now. So first of all, there are companies that can't use SPL because they don't understand it, they're afraid of that, and I would say rightfully so. Those companies tend to be big companies with big data sets, and therefore right now FerretDB is not suitable for them. We still talk with them, surprisingly. They're like, okay, so let's make a call like in several months to see where we are. Okay, I said two reasons actually, they're free. Second reason is some SaaS companies reach to us to ask, okay, are you production ready yet? Can we provide FerretDB as a service for you? And we say, well, not yet, but soon. will reach GA, and then you could like build a SaaS on top of that. And we are fine with that. I mean, that's why we are doing that. And second, there are companies that already use PostgreSQL. And there are companies that already use MongoDB for some applications that works only with MongoDB. And they don't want to support both databases, have two database teams, have experts in both of them. It would be easier for them to just have a team of PostgreSQL experts. That's all.
Okay, thank you.
Alexey, before you walk out to the discussion zone, we need to pick one person whose question was the best.
Okay, so I have this emotional support gopher, and I'm going to gift it if you want that gopher more than what you're going to give away.
We have a piece of merchandise.
Okay, so I'm picking two questions.
Two questions, okay.
Yeah, the first one was somewhere here. The first one. Do you want
the first one on the first.
Yeah.
First row.
Do you want gopher or? Okay. Okay, and the last one is the second question.
All right. Thank you, Alexey.
Thank you.
So, guys, please don't forget to rate the talk. 5 o'clock is the last talk on this stage. It's going to be about Foundation database.
Yeah. Check out this fancy QR code. It actually works.
Yes, scan all the QR codes. Have a great evening, guys.